All right, let's roll on with 4.2 here, talking degrees and radians. So 4.2a, so 4.2 is another massive section, and we're actually going to split it into three different parts, 4.2a, 4.2b, and 4.2c. So this one is just about degrees and radians, and really what we want to do is to convert the degrees to radians and then vice versa. That's kind of what we're looking to do. That's the main point here. But just kind of going over some things, understanding parts of an angle. So just kind of getting these down where we understand them a little bit more in detail and going that route. So let's first start by labeling the parts of the angle. Here we know right down here is the vertex. Okay. That's this part right here. Okay. And then the two sides, we know they have two sides. This side here that kind of goes out straight along from the vertex, you know, at a 0 degree would be the initial side. And then if we think of them as like initial side, and then if we think about them as like a rotation type thing, from 0 to wherever the angle goes, then that's the initial side. The other side we would be called the terminal side. Okay, so if we go over to the other diagram here, where we have standard position, we call it standard position. What we talk about is number one, we've got the vertex is at the origin, and then the initial side is on the positive x-axis. So that helps us. We can say, well, we know this is the vertex, it's at the origin. And we know that this part right here then would be the initial side. So the positive x-axis, I'm trouble with my L's today, that would be your initial side. And then again, if we think about it as a rotation here going in this direction, I'm going to go across the y-axis just to kind of give us an obtuse angle. This part here, that would be our terminal side. Okay, so those are the parts of the angle, whether they're just a regular old angle or if they're in standard position on a coordinate axis plan system. All right, so when we think about that rotation, what we want to think about in terms of that rotation is if the rotation is in a counterclockwise direction. So I'm going to go counterclockwise. Okay, or we could say CCW, counterclockwise direction, and the angle is formed as a positive angle. So just like the example above that we gave, this one here, we're going counterclockwise. So this would be a positive angle. It would be over 100, positive, 110 or whatever it is, the obtuse angle. Okay. If it goes the other direction, meaning we're going to go clockwise, if we went this way, then that would be a negative angle here. Okay? So if we go clockwise, or if I said that was CW, okay, go clockwise direction, then that angle form is a negative angle. Okay, so we kind of talked about that a little bit. So again, just to kind of draw those a little bit better, again, if we go, let's say the angle was out here, and we did our rotation going this way, counterclockwise, then that would be a positive angle. And then over here, let's say it's this way, and from our initial side, if we went this direction clockwise, then that would be a negative angle. Okay? All right, so some common angular units of measure. The one that we use the most is called the degree. You guys are familiar with that? Okay, and so what we have to talk about here is a degree is equivalent to 1/360th of a full rotation. So thinking about that, and we talk about this would be CCW, counterclockwise. How about the vertex? Okay, so since there's 360 degrees in a full circle, just 1/360th of that would be 1 degree. Okay, so for the diagram down below, you can see that 360 degrees corresponds to 1 complete full rotation. 360 corresponds to 1 complete rotation. So, right, because if I'm at 0 and I go all the way around here, 1 complete rotation, that would be 360 degrees. Okay. We also know that 180 then would be 1/2 of a rotation. And we can continue on with that, saying 90 degrees is put degrees there. And 90 degrees would be 1/4 of a rotation. And we can continue on. 45 would be 1/8. You can really put some other things in here. If you wanted to go with 3/60th, I'm sorry, if you wanted to go 30 degrees, if you wanted to go, say, 60 degrees instead, that would be 1/6 of a rotation. 30 degrees would be 1/12. If you want to just put those down, just so we know if we need them later on. Okay, and there's that circle, right? So if we think about 30 degrees, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/12 would be every 30 degrees. Okay, so just an idea there. All right, so down here, we're just thinking about degrees, minutes, and seconds. Okay, degrees, minutes, and seconds. So sometimes when we label things, there's no, well, we'll get to that in a second, but if we have to kind of change these into like from decimals to minutes and seconds, we can do that. It's not the most important thing. It's pretty simple, but we'll just kind of keep this in mind here, that 1 degree equals 60 minutes, 1 minute equals 60 seconds, okay? 1 dash meaning minute, 2 apostrophes meaning seconds, okay? So let's just do that really quick for a couple here, changing 329 to 0.125 degrees, minutes, and seconds. Okay, so we know here that basically 329 is the degrees, okay? And then we're going to take this 0.125 and change it into minutes and seconds. So if I just kind of expand that out, it would be 329 plus 0.125. Okay. So if I take that, what I want to do is I want to multiply it by 60 over 1, because that's the degrees equal from back here. If we take a look, right, 1 degree equals 60 minutes. So if I multiply by 60 here, I should be in good shape. Okay, so doing that, I'm going to leave that 329 alone because we already have that as the degrees. And then basically when I multiply 0.0125 times 60, I'm going to get 7.5. Or so that would be 7.5 minutes. Okay. All right, and again, I can, if I expand that out, I'm just going to go 329 degrees, and it'd be plus 7 minutes, and then 0.5 plus 0.5 minutes. So I'm going to take that 0.5 and multiply it by 60 over 1 again, okay? And that's going to change it to 329 degrees, 7 minutes, and 30 seconds, because 0.5 times 60 will be 30. And that is our degrees, minutes, seconds. Okay, so let's say if I take degrees, minutes, seconds and go the other way, okay? I go the other way and change it back to a decimal, okay? So one thing to think about here is if I rewrite this, I go 35 degrees. So I've got this 12. I'm going to expand that out 12 minutes. And then, and then plus 7 seconds. Okay. Well, what I'm going to do here is the minutes I know are 1/60 if I want to turn that minute into a decimal. And then over here, the seconds, though, if you think a minute is 60, and then so a second is another 1/60th. So really, I've got to multiply this by 1/60 times 60. So 1/3600. Okay. So with that being said, we can go to 35 degrees here. Nothing changes there. The 12 times 1/60th is going to be plus 0.2. And then over here, 7 times 1/360, or 3,600, will be 0.002. So then I combine those and just add those up, and it's going to be equal to 35. I put my decimal here, 0.2002. All right, so continuing on now. Just another thing with that idea of looking at this rotation here. Oh, how did that happen? Just isolate this thing. Good, let's bring this down a little bit. I don't know how that happened, that got up there. Yikes. Okay, so let's isolate this circle here for a minute. All right, so when I'm looking at that, remember that a whole rotation, right? That's what we were talking about. This whole rotation is going to be 360 degrees. So we kind of need that idea as we go on to this next problem where we're looking at the wheel on a truck with a 3-foot diameter rolls in a straight line. So we're talking about the wheel in a straight line with a 3-foot diameter, rolls in a straight line, and turns a total of 6 million degrees. So how far has the wheel traveled in miles? Okay, so first thing I'm going to do is I'm going to look at, well, I went 6 million miles, right? 6 million miles. And so how many rotations was that basically, right? So if I divide it by 360, that's going to give me how many rotations, how many revolutions the circle makes. So basically what this is, because this is 360 is one rotation. So that's going to mean that the wheels went around, that wheel went around about 16,666.67 rotations. Okay. All right. Now that was our how many times it went around the circle. Now we want to go from oh yeah, so now the other thing is we have to look at the 3-foot diameter. So how many times did that go around? What was the distance that went around? So the other thing we got to look at here is circumference, right? Because the wheel goes around, the rotation is the circumference of the circle. So C equals pi times diameter. Okay, so we know here that we've got pi times the 3-foot diameter, which gives us about 9.42 feet, because this was in feet, right? So now I can take the amount of times that the wheel turned around, the 16,000 and change, and multiply that times 9.42. And that will give me 157,000 feet. Okay, now I have to change that into miles. So I do that by dividing by 5,280 feet in a mile. So that would give me about 29.75 miles. Okay, all right, so now let's get to the most important stuff on the stuff here. And this is basically, we're looking at radians. Okay, so the measure of radians in the circle is equivalent to the side length of the arc there, the intercepted arc S divided by the radius of the circle. Okay, the reason we need radians is that we don't have any connection between distance and degrees and distance. So in order to do that, we have to use a different thing like radians. Okay, so if we look at this examples down here, what we can find is that one rotation we know is the circumference, 2 pi r, right? This is circumference, okay? 2 pi r divided by the radius would be one full rotation. So these r's are going to cancel out basically, and we could say that 360 degrees is equal to about 2 pi radians, and we just use radians for that, okay? All right, now 180 degrees, so if we take 1/2 of that, and really we're just going to use the 2 pi because we know those r's are always going to cancel out. So 1/2 of 2 pi would be pi, so 180 degrees would equal pi radians. Same thing if we keep going, 90 degrees would equal pi over 2 radians, and then 1/6, right, that would be 60 degrees. Would be all of those. Okay, so that's kind of how we convert to radians. So knowing that idea, what we're going to do is we're going to use these practice problems and just convert from degrees to radians and vice versa. And all we need to do is we're going to go from a degree to radians multiplied by pi radians over 180. And the opposite here, if we're going from radians to degrees, then we want to multiply by the reciprocal of that 180 over pi radians. Okay, so let's do some examples of that to show you how it's done. Pretty simple stuff here. Okay, so we've got this 210. So we're going from degrees to radians. So from degrees to radians, I'm going to multiply by pi radians over 180. And basically what that's going to be is 210 over 180, which equals times pi radians, basically, which then just going to reduce this to 7/6 pi. And that's it. Okay, that's all I have to do. All right, let's try another one, -60. So we're going to take this -60 and multiply it by pi radians over 180. So I'm just going to take that -60 and put it over this 180 times pi radians. And I can reduce there, -1/3. Don't forget about the pi. Okay? All right, going in the other direction. So now we're going from radians into degrees. So to do that, right, we're going to take 4 pi over 3, and we're going to multiply this by the reciprocal of what we did earlier, 180 over pi radians. And so now multiplying across, what I'm going to get is 4 times 180 is going to be 725 divided by 3. And I still have that pi there. And so those pi's are going to cancel out. So 720 divided by 3 is equal to 240 degrees. 240 degrees. All right, last one here. Take the pi over 6. Multiply it by 180 over pi radians. Okay. That's a -1 basically, so it's -180 over 6. And don't forget, remember those pi's are going to cancel, and you can cancel them here if you want. So it's basically -180 divided by 6, which equals -30 degrees. Okay, so that's the main focus, is changing those to and from radians to degrees, and from degrees back into radians. All right. So bring your questions, and we'll continue on with that next time I see you.